Today we will discuss about the thermodynamics, which is basically a Greek word here, thermi meaning heat and dynamics power, which is basically the most descriptive of the early efforts to convert heat into power. Today, the same name is broadly interpreted to include all aspects of energy and energy transformations, including power generation, refrigeration, and relationships among the properties of matter. Before going into the advanced level of this thermodynamics, first we will try to understand some of the very basic concepts involved in thermodynamics. First is system. What is a system? It is basically a system is part of universe, is that part of universe which is under thermodynamic study. And the rest part of the universe, part of universe is called simply surroundings. So we have basically two terms here. One is system and the other one is surroundings. And one more point regarding the system you have to remember is that it is made up of one or more than one phase. And this system is, if it is made up of one phase, then that system will be simply called as homogeneous. That means the system can be homogeneous, or if it is made up of more than one phase, simply heterogeneous. Now, what is this phase basically? We will try to understand it here. First, we will understand this phase. First point you have to remember about the phase is that it is a homogeneous physically distinct and mechanically separable. Separable portion of universe. Separable portion of universe. Suppose we will quote here a simple example. For example, if you take a beaker and first what you will do, you will add simply water in this beaker. This is water. Now what we will do, we will add a layer of oil in it. Suppose this is oil layer. You will see that there are two layers will be formed. So here this water is homogeneous, one phase, and oil is another phase. So this is basically a heterogeneous system. Now for homogeneous, you can simply take water and add pinch of salt or sugar in it, and it will dissolve and it will result into the homogeneous and physically distinct and mechanically separable portion of the universe, okay, or this system. So here what is meant by mechanically separable, that means if you take a separating funnel here, what is a separating funnel? In organic chemistry we use this separating funnel very often to separate two phases, okay. Suppose this is made up of borosilicate glass or simply glass, and what you will do, you will add both, that means this heterogeneous solution, and one part will be water, other will be oil. This is water and the upper portion will be oil, because density of oil is less than the density of water, okay. What you will do, you will simply open, here is a knob, you will open that, and first layer that comes out will be simply water, and similarly you can do for the second layer also. So in the second layer it will be only oil, so you can take this portion in the other beaker. So that is, we have separated these two phases mechanically. Now we will discuss here the types of system. So depending upon nature of boundary, basically you have to remember nature of boundary, what kind of boundary is separating two phases, you can say. Nature of boundary are between system and surroundings. We can divide these systems into, first one will be the isolated system. The second will be the open system. Third will be closed system. So what is now isolated system? If the boundary basically prevents any interaction with the surroundings. Or you can say, then it can neither exchange neither exchange energy nor matter, which is surroundings. So that system will be simply called as isolated system. Now, an open system is simply if both this matter and energy can pass across the boundary. You can simply take the example of a tea kept in a simple cup. Here, in the isolated system, the example will be a cup of tea in thermos flask. That is not the perfect example, but we, we are taking that as isolated system, that it can neither exchange energy nor matter with the surroundings. So what in this open system, if this is the hot tea here, the vapors as well as it is vapors will go into the surroundings, that is matter is exchanged. Its temperature will come to the room temperature, so its energy will also be decreased. That means it can exchange both matter as well as energy. Now, the closed system is that if it can't exchange matter but it can exchange energy. that will be called a closed system. So example will be simply tea caffeine just in ordinary cafe. Now we have one more classification based on the processes. First we will see the thermodynamic process. What is a thermodynamic process? It is basically the path of operation by which a system changes from one state to another. That will be simply a thermodynamic process. We have different types of thermodynamic processes. For example, isothermal process. First one we will take. First one we will write here. Isothermal process. Simply, temperature of the system remains constant during each step. That means temperature remains constant during each step, and that means dT will be equal to 0. That means changing temperature will be equal to 0. So the first point we have to remember about the isothermal process is that for the isothermal process change, system should be contained in perfectly conducting container. System should be contained in a perfectly conducting container. The second point regarding this is the perfect isothermal change is impossible to achieve. Perfect isothermal change is impossible. But when a change is carried out very slowly, approximate isothermal change occurs. That means you have to carry out a process very slowly, then we can say approximate isothermal change has occurred. One more point regarding the isothermal process is that it follows Boyle's law. If temperature is constant, that means if we have an ideal gas equation, PV is equal to nRT. If temperature is here constant, this is constant, this is gas constant, this is also constant, so this is number of moles, this is that means PV will be simply equal to constant. So which is basically Boyle's law, or you can say E is inversely proportional to upon V. One more point you have to remember regarding the isothermal process is that work done basically work done in isothermal process is graphically given by area under pressure volume curve. That means if you plot a simple graph between suppose pressure and volume, suppose this type of curve is obtained, then area under this curve will give you the work done. One more point regarding the isothermal process is that if you take the change in enthalpy, which is related by mCp delta T. That means here Cp is simply the specific heat capacity at constant pressure. We know for a for an isothermal process this term is equal to delta T is equal to 0. That means delta T is 0. And if we are talking about the change in internal energy, then we know a relation mCv delta T. Here also this delta T for an isothermal process is equal to 0. So change in internal energy will be equal to 0. Thus, what we have to remember that for an isothermal process, change in enthalpy is equal to 0 and change in internal energy is equal to 0. And you have to remember this point also that the specific heat at constant temperature is infinitely great. Simply, we are discussing isothermal. So these were some of the pointers about the isothermal process. Now we have the second one that will be called an adiabatic process. So basically in adiabatic process there is no heat exchange between the system and the surroundings. That means we can write Q is equal to constant as there is no heat exchange between system and surroundings. When Q is equal to constant, that means the change in Q will